This is the second in a two-part series on Experiment 11 on Light and Sound from Charles Platt's Make Electronics Second Edition. We start with the LED blinking circuit from the first part of the series with a 1.5 second on versus off time for the LED that was achieved using a 3.3 microfarad and 470 kilo ohm RC network combination. We're going to modify that to bring up the frequency. Now, frequency is approximately 1 over the time constant from the few hertz or few cycles per second to the millisecond time period, or 200 or so hertz in the audio frequency region, by changing that 3.3 microfarad capacitor to a 0.01 microfarad capacitor. And we're going to connect the speaker through a second capacitor which acts to block some low frequencies. So we're going to start off with a large capacitor value of 220 microfarads that will be like a open circuit for low frequencies, that is signals that don't change in time, allowing our speaker to just change from the oscillations in the circuit. With that done, we're then going to try another little modification, which is to make a little bit more of a pure tone. Just to experiment around a bit, and now put a capacitor across the speaker. By doing that, now the high frequencies, which are preferentially passed by the speaker, will go through that crossing capacitor and avoid going through the speaker, therefore getting rid of high frequencies in the signal. And make sure you do that back and forth a few times and can listen to the difference. Okay, here's our procedure for building the full circuit. So we're going to duplicate the audio circuit that we just built on the bottom of the breadboard. And now it shares absolutely nothing between the top and bottom circuits except for a power connection, which is over on the left side of the circuit. So we're connecting the power for the audio circuit also to the rail. To begin with, there is no connection whatsoever between those two halves of the circuit yet. And so independently, we should see it flashing the LED, whatever frequency we brought it back to, say the 1.6 second on versus off time. And then also, we should hear speaker buzz in the lower part. Again, no connection between the top and bottom. The idea here is to build our circuits in a modular fashion, getting one piece working at a time, and then connect things together when we're done. Remember, you can help hear your circuit a little bit easier with a paper roll. The next step is now to take the power to the lower circuit and remove it. That will stop the speaker from buzzing, and reconnect the power to be going through the LED flasher circuit. So keep the LED in there. It's nice to know when we're turning on and off our buzzer. And the LED, we know, doesn't draw much current when it's being current limited by that kilo ohm resistor. And just tap off the power before it goes to the LED so that we're modulating with that low frequency oscillator, sometimes called a LFO, the speaker. You should now hear it pulsating, whereas it was steady before. Power to the lower audio circuit is only present when the LED is on. Now, in addition to just flashing, we could, say, make that LED pulsate, right, by changing the transient time on and off. We can change the repetition rate, do a whole lot of different interesting modifications, and that's what we're going to look up next. To make our life easier to listening to that, I've actually hooked up the output, instead of using the small speaker included in the kits, instead hooked it into a pair of amplified speakers. Now I use a cheap pair of amplified speakers. This is a pair that's got a bad connection I had laying around in the basement. This allows us to hear much easier. So you can optionally do this if you want. You'll probably clip to the top and bottom of that 3.5 millimeter stereo lead you have coming out, and put it exactly where I had the speaker before in the circuit. Now we can clearly hear the pulsating, ramping up and down of the volume of the audio circuit versus the flashing. And then we can also go and start changing some things around. For instance, change the pulse repetition rate. We can change the pitch of the circuit, the time spent on versus time spent off by changing the two capacitors in the upper circuit, a triangle versus square modulation. You'll hear that in a moment. It'll actually chirp the pitch or change the frequency from low to high or high to low as the voltage ramps up and down on the audio circuit, or change the triangle versus square wave tone. So just take some time and play with some modifications to your circuit. Make some interesting noises. You should probably even inadvertently discover how to make impressive white noise or static at some point. Just be careful of too many cross wires. Finally, you can also think about a pitch adjustment. Take a large value potentiometer, like your mega ohm or half mega ohm one, and put it in series with one of the 470 kilo ohm to adjust the pitch. For this experiment assignment, I would like you first to simulate and spend some time playing with just the audio portion of the circuit, just the part without the modulation, so we did in the first half of the video. Model the circuit using the Lush Project's circuit simulator, and see if you can replace the LED with an audio output element. You can find audio output under outputs, and they can be a little bit tricky, but once you get it done, it's really nice because if you use that plus the oscilloscope, you can record an audio waveform for a while. Once you get at least 10 cycles, you can then actually play it back. There should be a little play button that appears to get your tone. Please place a brief video of the simulation as well as your audio circuit in your logbook. Then go ahead and build the full modulated audio circuit as shown in figure 2-120. You don't need to simulate that, but you should place a video and audio clips of interesting sounds in your live notebook, along with any interesting modifications that you may discover. Please post an audio clip to the online discussion board to share your work with your classmates. Make sure you leave your breadboard intact. You're going to take a little break from breadboarding to learn some soldering skills and come back and move this circuit onto a breadboard, or part of the circuit onto a breadboard in experiment 14, the wearable pulsating glow.